Hello Legacy students, so Marsh here. Today we're going to find angle measures of polygons. What you're going to want to have on you is the guided notes that you received in class, calculator, and then also a pen and pencil as well. Very first thing we need to talk about. What does it mean to be concave and what does it mean to be convex? And you're going to hear those words when referring to a polygon. Well, concave means that you have angles that point in towards the shape. So they're pointed inwards. Convex means no angles point in to the shape. So if I look on this shape here, notice how each of my angles here, they're all pointing outwards, not pointing towards in. This would be a convex shape. Concave, notice how these two angles, they kind of look like they're pointing in. This would be a concave. A good way to remember that this is a concave polygon is that it is caving in. It looks like it's kind of caved in or been pushed in on two sides. Most of the time, however, we'll be looking at convex polygons just because they're more of a normal shape. We've seen them more naturally than a concave one. Another definition we need to talk about is what's known as a regular polygon. A regular polygon has all congruent sides and congruent angles, aka they're equilateral and equal angular. So that means every side is congruent and so is every angle that is congruent. And I would draw this little diagram over here so that way you have an idea of what that's going to look like. Now, in a triangle, we knew that the interior angles equal 180. We're going to need to know more of those ability or just how to receive that or get that for shapes that have more than just three sides. So I'll put a little note here. We got sides and then we got interior angle and then we'll put sum. So how much do they add up all together? So triangle, we know that is three sides and we know there's 180 degrees inside of a triangle. So if I take all three angles and I add them together, I should and will get 180. Quadrilateral, we've kind of been looking at already. There's four sides to him. Now, here's the reason we've been talking saying he is 360 degrees. Here's the reason he's 360 degrees. If I take him from one vertex and go to make triangles, I can only make two triangles, right? Well, that would be 180. Each of those have 180 times 2. That's 360 degrees. That's how I can find out for almost every single one of these. So pentagons have 5 sides. Now, from each vertex or each point, how many triangles can I draw? Well, I can't draw over here. That wouldn't be a triangle. So I'll go one across, right? And then one down here. So I will draw 1, 2, I drew 3 triangles in my pentagon. So that would be 3 times 180 because each one of these guys has 180 in it, right? Well, that would be 540 degrees interior angle. So all 5 of these guys add up to 540. Hexagon, that has 6 sides. Let's see how many triangles I can draw. I go 1, 2, 3, right, can't draw there, so I got 1, 2, 3, 4 triangles. So 4 times 180, I will get 720. Heptagon, you'll also see this called a septagon, depending on who you talk to. That is a 7-sided figure. I can draw in 1, 2, 3, 4. 4 lines. 1, 2, 3, 4, 5 triangles. So 5 times 180. I will get 900 degrees inside of a heptagon. Octagon. Now, you guys have seen octagons before. That is 8 sides. It's the stop sign shape. I can draw in 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. I got 6 triangles I can draw, so that would be 6 times 180. So I will get 1080, 1080 degrees. Move over to a nonagon here. That is 9 sides. My goodness, this is going to be a lot of triangles here. Lots and lots and lots and lots of triangles. There we go. So I got 1, 2, 3, 4, 5, 6, 7 triangles. So 7 times 180, that is 1260. Okay. Decagon, that is 10-sided figure. What I got here? How many triangles? It's been kind of going up though. 6, 7. You know what? I bet this is going to be 8. I bet I'm going to be able to draw 8 triangles. 1, 2, 3, 4, 5, 6, 7. Whoop! I was right. 8 times 180 for my decagon. Well, that is 1,440 degrees. Now notice we skipped the 11-sided figure. We went to dodecagon. He is a 12-sided dude. I will tell you, because that is going to be a small shape, lots of triangles. There are 10 triangles that are able to be drawn there, times 180. So I have 1,800 degrees available inside of a decagon. Now you're probably saying, I don't want to draw a whole bunch of triangles. That's going to take forever. So the sum of an interior angles of a convex polygon with n sides. Notice, guys, the number of triangles was the number of sides, but subtract 2. Every single time. So to find the sum of my interior angles, what I'm going to do is I'm going to go n minus 2, number of sides, minus 2 times 180, aka this is going to find how many triangles can I draw in said shape and multiply by how many degrees in that triangle. Now, if you have a regular polygon, you know that each interior angle is the same amount, right? Because it was equal angular. So what I can do is find the sum of them and then divide by the number of sides we have. So if I want to know how many degrees are inside of a pentagon, I would have 540. Then I would divide by 5 to know if it's regular, how many degrees of each of the interior angles. Let's try a couple of examples. What is the sum of the interior angles of a convex dodecagon? So I need to use my formula. N minus 2 times 180 degrees. So 10 dodecagon, that is 12 sides. So I'll go 12 minus 2 times 180. That's 10 times 180, which is 1,800 degrees. Now let's say I wanted to find, let's say this was a regular dodecagon as well, and I wanted to find how many degrees are each of my angles, each of my 12 angles. So what I would do, I know the sum is 1,800 degrees. If this is regular, each angle is 1,800 divided by 12, number of angles I got. So 1,800 divided by 12 is 150 degrees. So almost perfect straight lines, but just a little off. So each angle, if it's a regular dodecagon, would be 150 degrees. Let's try another one. So if the sum of the interior angles of a convex polygon is 2,340 degrees, then how many sides does it have? Well, this is using that formula, right? But we don't know the number of sides, so we're going to keep our n there. N minus 2 times 180 equals the sum, the answer I got, the answer they gave me, so 2,340. Well, I could distribute the 180 in, so I'll get 180n minus 360 equals 2,340. Looks like I have to add 360 because I'm going to solve for n, right? So I'm going to add 360. 180n equals 2,700. Yep. Divide by 180. So I get n is
Let me do that on my calculator quick. 15. So I have found that this is a 15-sided gon, which would be a 15 gon. Normally that's what you'll write if you have a multiple-sided above 12. You'll say the number hyphen gon. Let's find the other one here. Find the measure of the missing angle. Well, how many sides are this? 1, 2, 3, 4, 5-sided. So this is a pentagon. Let me look back here. How many degrees inside of a pentagon? Pentagon had 540 degrees, which I could use my formula to find that as well if I didn't know that off the top of my head. So I know that all 5 of these angles inside here have to add up to 540. So I'm going to write that out. 110 plus 92 plus 84 plus x plus 100 has to equal 540. Now, let's combine all of these numbers together. That is 386 plus x equals 540. Need to subtract 386. So I get x equals 154 degrees. Yeah, that's right. Alright, let's take a look at exterior angles now. You're probably like, what's an exterior angle? Well, ultimately what it is the angles that are swept out if I extend each side here. It's the angles that are left behind after you cut off the sides. So I marked in all the exterior angles here. Now let's figure out how many. Is there a formula for it or something like that? Well, this is a pentagon, right? And I know a pentagon has 540 degrees for a sum of interior angles. I'll go 5 minus 2 times 180. Well, I have 5 regular, this is a regular pentagon, I have 5 angles for that to share. So I'll divide by 5. So each of them is 108 degrees. So this guy is 108 degrees, this guy is 108 degrees, so is this guy, so is this guy, and so is this guy. Well, here's the thing. I know that these two angles, the exterior plus the interior, has to make 180 because they are a linear pair. They form a line. So, 180 minus 108, that would be 72 degrees. Yep. So this is 72. Same thing here. Same thing again. Same thing again. Same thing again. Now, if I add up all the 72s, or technically, I'll take 72 times 5, I will get 360. Now, here's the real cool thing about exterior angles, the sum of them. No matter what, it could be a 100-sided polygon. Your exterior angles will be added up to 360 no matter what. Always, always, always will your exterior angles add up to 360. Each exterior angle, if it's regular, are always going to be the same amount. Just like on this one, that all of my exterior angles were 72 degrees, that will always happen in a regular polygon. Now, let's take a look at an exterior angle problem. I need to find the value of x. So I got this exterior angle, this one, and this one. Well, all exterior angles add up to 360. So I'm going to add all my exterior angles up, set it equal to 360 degrees. Let's combine like terms. So I got an x and another x, so that'd be 2x, 20, 96, and 112. That is, quick on my calculator, 228. That equals 360. Looks like I need to subtract 228. So I get 2x equals 132. Divided by 2. That is 66
x. Whoops. X equals 66. And that's the end of this video. I'll see you later, Sabers.